Well, hi everybody. Cinco de Mayo's on Tuesday. How even are you? Today, we're here to learn about what's so special about hydrogen ions anyway. Because we're talking about acids here. And I said that an acid is a salt where hydrogen is the cation. So if you take any of these other cations, all this is cations right here, all that. You take all those and put them on any of these anions or any of these anions back here, and you get just a regular old salt. But if your cation is a hydrogen ion, an H plus ion, then your salt is an acid. Why? What's so special about hydrogen ions? That's what we're here to suss out. Okay, so let's look at, I don't know, let's look at beryllium, which forms a 2 plus ion. Want to do that? Fine. Beryllium. So in the center of beryllium, we have a nucleus. And in a beryllium atom, we have four. You can believe me that there's a 4 right there. We have 4 protons. 1, 2, 3, 4 protons. And that's not all that's in the beryllium nucleus. There's 9 total particles in the nucleus, 4 of which are protons. So what that means is that there's 5 neutrons in the most common isotope of beryllium. And we didn't spend any time on that. So if you don't know how to do that, don't even worry about it. You can just take my word for it. But there's 1, 2, 3, 4, 5 neutrons in there. 4 protons and 5 neutrons. Then there's 4 in a neutral beryllium atom. There's 4 electrons. So 2 of those are going to be in this first energy level. There's an electron there and there's an electron there. And then in this second energy level, which has 4 of these orbitals, in the second one, we've got 2 electrons. 1, 2, for a total of 4 electrons and 4 protons. So that would be a neutral beryllium atom. But of course, you never find beryllium atoms like that. You pretty much always find beryllium atoms as ions, because this is very unstable to have an outermost energy level that's not full of electrons. So what happens is the beryllium donates these 2 electrons to another atom, or another atom takes it from it. And then what we end up with is beryllium 2 plus, which is going to have 2 electrons in the outermost energy level, and then it's going to have 4 protons and 5 neutrons. Like that. And that's what beryllium is. Big deal. I had to show that to you to make you understand what's so special about hydrogen ions. Let's start with a hydrogen atom that's neutral. How many protons does it have in it? That's right, it's got 1. 1 proton. How many neutrons does it have in it? Well, it has 1 total things in its nucleus, 1 of which is a proton. So that means it doesn't have any neutrons, actually. You can have an atom without neutrons. That's okay. And then how many electrons does it have? It's just got 1. So we could draw that electron right there like that. So this hydrogen atom needs 1 more electron to get this full outermost energy level. But the problem is there's only 1 proton pulling on electrons, so it doesn't have a lot of pull to it. It's real hard for hydrogen to take an electron from another atom. So instead, what happens is another atom takes an electron from hydrogen. And what you end up with is an atom which has a nucleus made of one proton, and then it's got no electrons. So another way to look at that would be like this, because if there's no electrons there, then it's kind of like it's not even there, right? So another way to look at a hydrogen 1 plus ion, oh yeah, and by the way, this is a hydrogen 1 plus ion, right? So another way to look at that is it's just a nucleus with a proton in it. But the thing about nuclei, that's the plural of nucleus. The thing about nuclei is they're not like a sack that contain things. All they are is the things they're made of. So what's a hydrogen nucleus made out of? It's made out of a proton. So here's the big deal. What's the difference between a hydrogen 1 plus ion and a regular old proton? What's the difference? Guess what? There is no difference. A hydrogen ion is a proton, and a proton is a hydrogen ion. Another way you could think of it is that a beryllium atom has 4 hydrogen ions in its nucleus because there is no difference between a hydrogen ion and a proton. They are exactly the same thing as we just showed right here. So what's so special about hydrogen ions? The special thing is that they're the same as protons. And we spent a bunch of time learning how chemical reactions happen because electrons, which are charged particles, are passed from one atom to another. Well, here's another way that a chemical reaction can happen. A chemical reaction can happen by protons being passed from one atom or from one molecule to another. And that is to say that hydrogen ions can be passed. And that's exactly what acids do. And that's what the subject of tomorrow's lesson's going to be. Well, I sure do miss you guys a bunch, and I hope I get to see you by the end of the year. But if not, I'll see you in real life in August.